Today's lesson is Chapter 5, Lesson 2, which can be found on pages 309 through 314. Our objective is I can estimate sums and differences by rounding with decimals. Vocabulary is sum, difference, round. Question 1, numbers 1 through 4, round blank. Numbers 1 through 5, round blank. Question 2, round 46 and 961 thousandths to the nearest whole number. Okay, let's watch this brain pop on rounding.
Dear Tim and Moby, what does it mean to round a number? I'm curious. Thank you, Jeanette. When you round a number, you change it to a simpler one with roughly the same value. It's basically an estimate. No, you can't just choose any old number you want. There are some rules you have to follow. When you round something, first you have to decide what place value you want to round to. A digit's place value is its position within a longer number. For integers, or whole numbers, the lowest place value is the ones place, followed by the tens place, hundreds, thousands, and right on up. Take these marbles. The package says each bag contains 17 of them. But say we wanted to round that number to the nearest 10. 17 is only 3 marbles away from 20, but it's 7 away from 10. So 17, rounded to the nearest 10, is 20. Let's try 14 marbles. 14 is closer to 10 than 20, so we round it down to 10. Right, if a number ends in 1 through 4, you round it down. If it ends in 5 through 9, round it up. This video game says it has 345 levels. To round to the nearest 10, look at the digit to the right of the tens place. It's 5, which means you round up. So far, so good. But what if you want to round it to the nearest 100? Same idea, but you're going to look at the digit to the right of the hundredths place instead. It's a 4, so we round down. 345 rounded to the nearest 100 is 300. And you can do that for any number, no matter how big. Just look at the digit to the right of the place value you're rounding to. Yeah, it's the same for decimals, only you don't put a 0 on the end. Like, say you want to round 3.45 to the nearest tenth. You look at the digit to the right and round based on that. In this case, it's 5, so we round to 3.5, or 3 5/10. But because it's a decimal, we don't need to write the 0 on the end. Well, rounding's useful in a lot of real-life situations. Like now. I only have $50 with me, but this kite costs $15.33, the candy bar costs 99 cents, the marbles cost $3.75, and the video game costs $29.99. I could add up all those numbers, but I don't have a calculator, and it's kind of inconvenient to pull out a pencil and paper and write it all down in the middle of a store. So I'll round the numbers. It's a lot easier to add 15, 1, 4, and 30. That makes $50. Although, that's a little too close for comfort. Let's see what the exact price is. Rats. See, that's why it's always good to round up when you're working with money. Double rats. Can I borrow $5? Ow, what'd you do that for? I do so know the value of $1.
Okay, so if you look at page 309 in your textbook or online, it shows you some really good steps for rounding here. So in this example, it says, Hadasha used a digital thermometer to find the morning temperature and afternoon temperature. She found the morning temperature was 31 and 3/10 degrees Fahrenheit, and the afternoon temperature was 37 and 6/10 Fahrenheit. Estimate the difference in average temperatures. So one way here is to round to the nearest 10. So we can round 37 and 6/10 up to the nearest tens place. So if I'm rounding to the nearest tens place, then I will look at the number to the right of it. So I'm looking at this 7 to determine if I'm rounding up or down. So since it's above 5, I'm going to round up. So I'll round 37 and 6/10 to 40. And then I'll do the same thing for 31 and 3/10. I'll look at the 1 to know the ones place because it's the place value to the right of the tens, to know if I should round up or down. So the 1 is below 5, so I know I should round down. So I'm going to round down to 30. Then I can subtract 40 minus 30 because I'm looking for the difference in temperatures, which would just give me 10. Another way here is to round to the nearest ones. So if I'm rounding 37 and 6/10 to the nearest one, I'll look at the tenths place because that's the place to the right. So the 6 is greater than 5, so it tells me to round my 37 up to 38. And then my next one is 31 and 3/10. So I'll look at the tenths again because I'm trying to round my ones place. So I look to the place value to the right. That 3 is below 5, so it tells me to round down. So I'm going to round down to 31 instead of 31 and 3/10. Now I can more easily subtract, and I know I'll have 38 minus 31 will give me 7 degrees Fahrenheit. So the difference is about 10 degrees Fahrenheit or about 7 degrees Fahrenheit. So the actual difference, if you were to work it out, is 6 and 3/10 degrees Fahrenheit. So rounding to the nearest ones gave us a more accurate estimate because we weren't changing the numbers as much. So that's why we need to learn to round our decimals so that we can round as close as possible. Okay, let's look back at these questions and make sure you answer them on the form. So question 1, it said this directly in that brain pop, so if you need to go back and look. And question 2, actually round this number, 46 and 961 thousandths, to the nearest whole number. To the nearest whole number. So think about how you do that and type in the form what that nearest whole number would be.